Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif E-Didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Dan salam sejahtera. Hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Selamat datang ke Pusat Tuisyen Akademi YouTuber, usaha sama E-Didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, lamanya percuma. Untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan kelas dengan membaca doa mengikut agama masing-masing. Apa khabar para pelajar yang cikgu kasihi semua? Harap semuanya dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada petang ini. Cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas kita kali ini. Cikgu perkenalkan diri dahulu. Nama cikgu Teacher Tan dari Kolej Matrikulasi Selangor selaku moderator pada petang ini. Kelas hari ini adalah kelas tuition kimia PRAYU. Pada petang ini, kita bersiaran secara langsung dari channel Cikgu Shahnon. Sesiapa yang belum subscribe Cikgu Shahnon, silalah tekan butang subscribe sebagai tanda sokongan kepada Cikgu Shahnon. Untuk pengetahuan semua, Cikgu Shahnon adalah dari Kolej Matrikulasi Pulau Pinang. Kelas ini akan berlangsung lebih kurang 1 jam. Bersama cikgu pada petang ini adalah Teacher Bibila dari SMK Tinggi Kelang dan Cikgu Mawar selaku pemerhati. Sebelum kita meneruskan kelas kita, suka cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa sopan dan gambar profil yang bersesuaian untuk tuntunan umum. Sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruang chat untuk menjawab soalan atau mengajukan soalan. Pada akhir siaran ini, link e-sijil akan diberi dan anda hanya ada 30 minit sahaja untuk mengisi maklumat. Pastikan anda menggunakan email e-didik sahaja. Cikgu percaya semua yang hadir pada petang ini merupakan pelajar-pelajar cemerlang dan mari kita tunjukkan disiplin yang terbaik. Oleh itu, cikgu harap semua memberi tumpuan sepenuhnya semasa kelas ini bersiaran. Tanpa membuang masa, cikgu serahkan kelas kepada Cikgu Shahnon. Dipersilakan Cikgu Shahnon.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Alright, I'll share my screen first. Okay.
Cikgu Shahnon, maybe you can start with giving the first code.
Oh, first code.
You can start giving the first code. Yeah.
All right. Our first code is number 9. Okay, number 9. Okay, I repeat. Oh, first code today is number 9. Number 9. All right. Okay. This is my poster. All right. This is my poster. Then, this is my profile. My name is Shahnon. Oh. Wait a minute. Okay. Okay, it's too sensitive. Okay, this is my profile. My name is Shahnon from College Matrikulasi Pulau Pinang, teaching experience 25 years, and this is my channel www.youtube.com/c/Shahnon channel. All right. Okay, this is our team, Kimia Prayu. Okay, we have a teacher Vivila, our control host today, teacher Tang, our moderator, me, Cikgu Mawa, our observer today, and teacher Kong. Okay, and here is our teammate in Prayu. We have mathematics, lead by teacher Im, and then biology Prayu, lead by Cikgu Faiza, and perakaunan dan ekonomi, lead by Madam Vizi, and the last one is physics, okay, physics Prayu, lead by Madam Rosmaya, okay. And this is portal of Academy YouTuber Malaysia. You can get more information from this portal, okay. All right. Today, we will learn electrochemistry. The subtopic is galvanic cell. Okay, our objective is to, number one, is define what is electrode potential, and then draw a voltaic or galvanic cell, describe the operation of voltaic cell, and then state the function of salt bridge, and express half cell equation and the overall cell reaction equation. And number 6, illustrate a galvanic cell using a cell notation. Okay. All right. What is a galvanic cell? What is electrochemistry? Okay, electrochemistry actually the study of electrochemical reaction in electrochemical cell. We have two types of electrochemical cell. Number one is galvanic or voltaic cell. Number 2 is electrolytic cell. Okay, and for galvanic cell, this is spontaneous reaction, but for electrolytic cell, non-spontaneous reaction. And electrochemical reaction, we have what we call redox reaction. Read mean reduction, ox mean oxidation. Okay. All right. Shamnurin from Form 3. Okay, no problem. Okay, definition. Okay, definition. For example, we have this equation, Cu2 plus aqueous plus zinc solid, and the product is Cu solid and Zn2 plus. What is redox reaction? If you look at this definition, redox reaction, reaction involving both oxidation and reduction occur at the same time. Okay. How do we know this is oxidation or reduction? We have to know the oxidation number. For example, in this case, Cu2 plus. Oxidation number of Cu2 plus is positive 2. And the product is Cu, copper. The oxidation number is 0. So from positive 2 to 0, that means this is reduction. Okay. And for zinc, for example, oxidation, because oxidation number of zinc here is 0. Okay, 0. And look at here, Zn2 plus, the oxidation number is positive 2. From 0 to positive 2, that means oxidation number increase. This is oxidation. All right. And this process occur at the same time. That's why we call it redox reaction. Okay, this is oxidation. Definition of oxidation: process that occur when species donate or loses electron. If you look at here, oxidation, this is zinc. It's donate electron. Okay, we will know how zinc donate electron when we look at the half cell. Okay, half cell, half. For example, like this, Zn, and then we have arrow here, Zn2 plus 2e. Okay, and then the oxidation number increase. We can see from here from 0 to +2. Okay. Why we have 2e here? 2e here because we want to balance this charge. The charge here is +2, and 2 electron here will balance the charge here because electron, the charge of electron is negative. So +2 plus -2, 0. Because here, if you look at our left hand side, the charge of zinc also 0. So here the charge is 0, and at our right hand side also 0. So that's why we put electron here. Yes, two electron here. Okay, the reduction process that occurs when species gain electron. For example, here Cu2 plus 2e. We have to add electron here because this is +2 plus 2e is become 0. And look at here, Cu here, copper, also 0. So the charge at left hand side and right hand side 0. So balance, this equation balance in terms of atom and also in terms of charge. Okay. All right. And then we have other term, we call it oxidizing agent. What is oxidizing agent? Species reactant that undergo reduction, okay, or gains electron. In this case, we know that Cu2 plus here reduced to Cu, and Cu2 plus we call it oxidizing agent or oxidant. Okay, oxidant or oxidizing agent. And then zinc here is reducing agent. Species reactant that undergoes oxidation, because we already know that zinc is oxidized to Zn2 plus, and zinc here we call it as a reducing agent or reductant. Okay, sometimes they call it a reductant. Zinc. Okay, zinc is reductant. Cu2 plus is oxidizing agent. Okay. All right. We still have a lot of definition. Okay. Spontaneous reaction, a reaction that has a natural tendency to occur and does not require an energy input for it to occur. Okay, we call it spontaneous reaction. For example, is Galvanic Cell. Okay, we will discuss Galvanic Cell after this. And the second example is rusting of iron. Okay, we have iron, for example. It takes time, maybe 2 weeks or 3 weeks, and it will rust. Okay, this happened spontaneously. Okay, and what is non-spontaneous reaction? A reaction that cannot happen naturally and need an energy input to have it to occur. Okay, this is what we call non-spontaneous reaction. For example, photosynthesis. Photosynthesis needs sunlight. Okay, sun ray, or electrolytic cell. Okay, electrolytic cell will, I think, my teammates will cover electrolytic cell next week maybe. And then what is electrode potential? The electrical potential difference produced between the electrode and the solution in the half cell. Okay, we call it electro potential, and it cannot be measured directly, right? And definition of cell potential between individual potential of the two metal electrode. We have half cell of metal and half cell of metal, and then we combine, and then it will become a cell, and we will get what we call cell potential. Okay, now look at question number 1. Copper solid plus 2 Ag plus aqueous, Cu2 plus aqueous, and 2 Ag solid. Identify the oxidizing agent. Okay. the question is oxidizing agent, right? And reducing agent. Okay, to answer this question, first we have to refer to this copper here. Copper oxidation number is 0, and then look at this here, copper oxidation number. This is how we write the oxidation number. Oxidation number means number plus and then 2. 2 plus here is this is not oxidation number. If we write like this, 2 plus is not oxidation number. 2 plus is charge of copper, right? So the oxidation number of copper ion here is positive 2, from 0 to positive 2. So we know that copper here, copper solid here is oxidized to Cu2 plus, right? And then Ag plus is reduced to Ag, okay, because this is positive 1 to 0, from positive 1 to 0 reduced. So oxidizing agent is Ag plus, okay. This one is Ag plus because oxidizing agent definition is species being reduced, okay. And then the reducing agent, of course, Cu solid. Okay, Cu solid. All right. I hope every one of you can understand it. This is basic of the electrochemistry, right? Okay. Okay. The oxidizing agent is reduced. Okay, as I said before, oxidizing agent is reduced, and the reducing agent is oxidized. Okay. All right. And then we still have a lot of definition. Electrode. What is electrode? Electrode must be solid. Okay, solid conductor, carbon rod or metal that allow electron to pass through it. It must be solid. Okay, this is electrode. And electrode anode is electrode actually can be divided into two, anode and cathode. Okay. Anode, what is anode? Electrode at which oxidation occur. Okay, oxidation will occur at anode. And cathode, electrode at which reduction occur. And this is how to remember. You just remember the red cat. Okay, the red cat. Red cat means reduction at cathode. Reduction always occur at cathode. Okay? Oxidation always occur at anode. So the easy way to remember is you just remember the red cat. Okay? Red cat, reduction at cathode. Okay, and we will use it so many times. Red cat. I'll show you later. Okay, this is cell diagram. Wow, what? This is cell diagram of zinc copper. Zinc copper cell. We call it zinc copper cell. This is what we call half cell. We have a half cell of zinc and half cell of copper here. Okay, and then a galvanic cell. Okay, this is galvanic cell. Consists of two half cells. We have zinc and copper in this example. A half cell consists of an electrode, as our definition. We have an electrode. The electrode must be solid. In this case, the electrode is metal strip. We have a zinc strip and also copper strip here, immersed in a solution of ion. Okay, this is its ion, zinc nitrate. Here we have a copper nitrate. All right. Okay. Zinc metal immersed in Zn2 plus is zinc nitrate, and copper metal immersed to copper 2 plus aqueous solution. Okay. And then connected by a salt bridge. Yeah. On the second code. Yeah.
The class code number 2. The second class
code.
Number
2. Right. Let me see first. The pass code number 2 is 8. Pass code number 2 is 8. Number 8, number 8. Okay. All right. Okay, this is anode. This is cathode. and then the two electrodes are connected by wire. We have a wire, we have a voltmeter, and short bridge here, and then short bridge here. By convention, the cell diagram, when we want to draw the cell diagram, the anode we have to write at our left hand side. Okay, this is by convention. The cathode, the reduction occur here. We have to write at our right hand side. Okay. All right. The two electrodes are connected by short bridge. We have a short bridge connected by short bridge, and also the wire. Okay, this is what we call galvanic cell. Right. All right. If you look at this cell diagram, we know the voltmeter here 1.103 here. How this why we have this reading? This is because of the electron flow from anode to cathode, and the circuit is complete. Okay, the circuit is complete. That's why we have a flow of electron and we have a electric current. That's why the voltmeter have reading here 103. All right. Okay. Look at here. We have a E naught of copper, positive 0.34 volt, and E naught of zinc, negative 0.76. Okay. E naught is electro potential. Okay. Electro potential of copper at standard condition. Okay. Copper metal is made the cathode Y. Okay. Y copper. Okay. This is copper. Is made the cathode. Okay, why? This is because of we look at the value here, the positive here. The more positive tend to accept gain electron and undergoes reduction. Okay, that's why we have to remember the red cat. Okay, I'll show it later. Easy for us to understand it better. Okay, cathode. Because more positive 0.34, so the cathode we made as the copper will be a cathode, Cu2 plus 2E. Okay, the anode is zinc, and then we have to write it in term of oxidation, right? Oxidation means it's lost electron at our right hand side. In this case, copper is gain electron. Electron is written at our left hand side. Okay. Okay, this is the same thing. This is anode. Okay. Electrons are released at the anode, as I mentioned before. The anode has a higher electron density. And then the cathode, as a result, the electron move from anode to cathode. Okay, I have now is 24. All right. All right. Look at here. This is anode. Okay, anode is here. At the anode, zinc 2 plus ion are produced and move into the electrolyte. Okay, and the anode here, the anode is zinc, and then the zinc will produce Zn2 plus. It means that Zn2 plus in the electrolyte increases. Okay, the electrolyte become more positive because now the zinc here, the electrode, the anode of zinc now becomes Zn2 plus. Okay, and then, okay. To maintain the electrical neutrality of the electrolyte, the anion NO3 plus from short bridge here, move to the electrolyte, move to here, so that it can maintain its neutrality of this electrolyte. Okay, because when zinc becomes Zn2 plus, the positive charge of this solution become increase. And to maintain it, the NO3 minus from the short bridge will move to this electrolyte. Okay, and the same thing goes to here. Okay, we look at this after this. Okay, how does the cell maintain its electrical neutrality? If you look at left cell, okay, Zn solid becomes Zn2 plus aqueous H2E. Okay, Zn2 plus ion enter the solution, causing the net excess of positive charge. And then NO3 plus from salt bridge move to the zinc half cell to neutralize the excess of positive charge. At our right cell, Cu2 plus become Cu solid. And what happened? The copper ion leaves the solution, causing an overall excess of negative charge. And then K plus ion from the salt bridge enter to the electrolyte to maintain its neutrality. Okay, this is the use of one of the use of salt bridge, okay, to maintain its electrical neutrality. Okay, still have time. Okay, a half cell equation. Okay, and then when we have a half cell, we have a at anode. This is oxidation. Zinc solid becomes Zn2 plus 2E. This is half cell of at anode oxidation, and then we have half cell of at cathode Cu2 plus 2E. Okay, it's become Cu solid. Okay, this is what we call half cell reaction, and then when we want to make overall cell reaction, okay, look at this half cell. We have electron, but for overall cell reaction, there is no electron anymore. We have to eliminate electron. How to eliminate electron? First of all, the amount of electron must be the same and at different side. Okay, anode, for example, the electron at our right hand side. At cathode, the electron at our left hand side. So we can cancel it. And the amount must be the same, 2E and 2E. So we just add Cu2 plus, this one, zinc 2 plus, okay. And then we have arrow, this is arrow. And then we have copper, this one copper. And this is zinc 2 plus, okay. Now it's become overall equation. Okay. Okay, before combining, this is a point to remember, before combining the two half equation, ensure the number of latent equations are the same, must be the same. If not, we have to multiply with the half equation by a factor, okay, to make sure they have same number of electron. Okay, 29. Okay, I think after this we will have a break. Okay, and then this is what we call cell diagram, and then we have cell notation. Okay, what is cell notation? Cell notation is a shorthand way of expressing a certain reaction in electrochemical cell. Okay, the cell anode and cathode are separated by two bars or slashes representing salt bridge. For example, we have K. Okay, we know that this is oxidation occur here, and this is anode. And for cell reaction, also a node, and our left hand side is a node. Okay. After this is a node, and then this is electrolyte. Okay, this is also electrolyte, and we put slash here because there is a different in terms of phase here. The phase of anode here is solid, and electrolyte is aqueous. That's why we put the slash here. And then after electrolyte, we see here this is a salt bridge. This is the symbol of salt bridge, double slash. And after that, this is electrolyte, and then the last is cathode. This is how we transfer from cell diagram to cell notation. I think now is 30 minutes. Okay.
Yeah, shall we stop for a break?
Okay, we can have a break.
Okay.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okay, welcome back.
Yeah.
All right. Okay, cell notation, right? This is cell notation, oxidation half equation at our left hand side, and reduction half equation at our right hand side. Same as what we draw the cell diagram, right? This is by convention, and this is also by convention. And then point to remember, phases of the reactant and product must be indicated. Concentration of ion or pressure of gas must be specified if it is known. Okay. And then slash represent phase boundary, comma, two species of the same phase. Okay. We will look at this after this. Double slash designated to the short bridge. And then we have oil. Oil is oxidation is on the left, as I said before. Where is number 5? Okay, number 5. Half cell component usually appear in the same order as in the half reaction, and electrode appear at the far left and right of the rotation. The electrode. Okay, and the electrode must be in solid conductor. Solid conductor. This is very, very important. Solid conductor. Okay. We look at. Okay, this is our cell diagram. Okay, we have a zinc as a electrode anode, and then zinc to plus, short bridge, and the plus and SO4 to plus. This is short bridge. Copper ion and copper voltmeter. Okay. How we draw the cell notation? First, we look at here, this is zinc. Okay, zinc becomes anode. Zn solid. Don't forget to write the phase of anode, zinc. And then after zinc is zinc ion. Zn2 plus ion, okay, aqueous. The phase is aqueous. If we know the concentration, we just write 1.0 molar. Actually, 1 molar is for standard, okay, for standard condition of this galvanic cell, we will use 1 molar. Okay, after that, this is short bridge, we use double slash, and then Cu2 plus, aqueous, 1 molar, and then slash, because we have different phases between Cu2 plus and Cu solid. All right, this is cell notation. And maybe we also have to draw this one, the flow of electron. Okay, if for cell diagram, we use this one, the electron flow from anode to cathode, and for cell notation also from anode to cathode. Okay, this is cell diagram, and this is cell notation. And make sure, okay, this is oxidation from 0 to +2, right? And look at here, from Cu2 plus to Cu. This is also reduction from +2 to 0. Okay, make sure all of this, and then our cell notation is actually same as cell diagram. Cell diagram. Okay, this is a second example. This is quite complex. Okay, we have what we call it She here. She is standard hydrogen electrode. Okay, how to write the cell notation? First of all, the anode must be solid. In this case, our solid is platinum here. Okay, PT is platinum solid. And then we have hydrogen gas here, bubble to this solution. The solution is H3O plus or H plus 1 molar. Okay, and the oxidation will occur here at platinum, right? So we write the hydrogen gas here. Hydrogen, the phase is gas, and 1 atm. Okay, the pressure is 1 atm, and then we add slash here because different in terms of phase. This is gas, this is aqueous, H plus, and 1 molar. Okay, so we settle to this part, and then we have a double slash here as a short bridge. All right, here this is the best part because we have Fe3 plus and Fe2 plus, and because Fe3 plus and Fe2 plus is not solid, we have to choose a solid conductor, and for this example, we choose platinum as cathode here. Okay, and then okay, make sure that we write it in reduction here. Fe3 plus aqueous 1 molar, and then we use comma here because same phase. Okay, we have same phase, aqueous and aqueous, so we use comma here. Fe2 plus, okay, same phase, we use comma, and then slash because different phase from our electrode platinum. Okay, platinum solid. Okay, this is how we write the cell notation of this cell diagram. This is quite complex. All right, and then the third one. Okay, look at the third one. Okay, this is oxidation, as I said before, from 0 to positive 1. Here is reduction from positive 3 to positive 2, right? Okay, okay, this is the third example. We have also platinum as an anode, and then we have a bromine because we know that bromine at standard condition is liquid. Okay, Br2 liquid. Okay, and then we have a Br minus aqueous here. Here we have a chlorine. Chlorine, we know that at standard condition means 1 atm at 25 degrees Celsius. Okay, chlorine at standard condition is gas. Okay, this is also quite complex. Okay, now how to write the cell notation? First, okay, this is platinum. Okay, platinum solid slash, and then we have Br minus here to Br2. Why? Because because Br minus, the oxidation number is -1. Br2 0. So -1 to 0 is oxidation, right? So Br minus aqueous 1 molar, and then slash because bromine here different phase with bromine. Br minus, Br minus is aqueous, bromine is liquid. Okay, bromine is liquid. So we have a slash, yeah. Here we have a slash. Okay, and we state also the concentration, and then double slash. Double slash is short bridge, no problem. And then chlorine gas. Okay, chlorine is gas, 1 molar, and so on. And slash, okay, slash because Cl minus is aqueous. Okay, 1 molar, and slash platinum. So this is how we write the cell notation of this cell diagram. Don't forget to write the flow of electron. Yeah. Oh, the second code. All right. And the third
Thank you,
code.
Shahnon. The third class code.
Okay, the third one is number one. Okay, the passcode number 3 is number 1. Okay. The third code is number 1. Okay. All right, we have a 4 code. All right, oxidation. Okay, make sure this is oxidation, and this is reduction. Okay. Okay. So summary for this galvanic cell. Okay. Galvanic cell means chemical from chemical to electrical energy, from chemical energy to electric energy. Okay. And half cell with more positive value is made in the cathode. Okay, reduction a red cat. Okay, more positive red cat. Okay, coming up next. Okay, we will. Okay, now this is our objective. We are running time 20 minutes. Okay. Define standard electro potential and standard cell potential. Draw and explain the standard hydrogen electrode of She, and state the characteristic of the standard reduction potential series and rank the oxidizing agent and reducing agent if their respective standard electro potential are given, and then calculate the standard cell potential. Okay. All right. Where is this? Okay. For standard state, I've mentioned this. Temperature 25 degrees Celsius, pressure of gas 180 m, and solid concentration must be 1 molar. This is standard state condition. And platinum is used as the electrode element does not exist as solid conductor. Okay, we will use platinum. For example, chlorine. Chlorine, no. Oh, what happened? Oh. Sorry. Technical. Okay. Okay, wait a minute. Loading. Okay, maybe we can. Okay. Okay. It's back. It's back now. Okay, wait a minute. Okay. All right. Still loading. Anyway, any question? No question. Okay, now we are here. I think here. Okay. Okay, this is a type of electrode of half cell. We have a metal and metal ion electrode. This metal contact with its solution, okay, containing its ion. And then the second one is gas electrode. We call it gas electrode. For example, our She hydrogen 1 ATM bubble to the its ion, usually H plus equals at 1 molar. And the third one is redox electrode like this, Fe3 plus and Fe2 plus. And then we have a redox electrodes. Usually we use inert electrode platinum. Okay, platinum or carbon. Okay, no, not this. Not easy to control this one, I don't know. Okay, this is electro potential. When zinc plate immersed in its ion solution, we will have what we call electro potential. There will be a equilibrium between zinc and zinc 2 plus. Okay, zinc and metal losses electron and zinc 2 plus gain electron. The equilibrium between zinc and zinc solid. And the electrical potential difference produced between the electrode and the solution, but it cannot be measured. And how to measure the electro potential? Okay, to measure it, okay, this one. To measure it, we have to use She, and then we connect with this half cell, right? We have to connect with standard hydrogen electrode, and the value of standard hydrogen electrode, She is 0.00 volt. Okay, and what is She? She consists of hydrogen gas bubble at 1 atm. Okay, bubble around a platinum electrode, which is immersed in 1 molar solution of H plus solution at 25 degrees Celsius. Okay, we have this as a half cell, and we have this one, zinc, have a half cell, and then we connect this, and it's become a galvanic cell like this. Okay, like this, we connect the zinc electrode and the She standard hydrogen electrode. Okay, and then we can calculate the potential here. Okay, the cell potential, we call it the cell potential here. When half of element of metal, M stands for metal, connected to hydrogen, half cell electron. Voltmeter reading is the cell potential. Okay, this is standard reduction potential of metal. We have sodium, magnesium, aluminum, zinc, iron, stannum, lead, and so on. Okay, we have, and this is the E naught of the metal. Or if you look at this standard reduction potential, all written in reduction form, Na plus plus E. Okay, Na become Na, Mg2 plus plus 2E, Mg, Al plus 2E, Al. All of this metal is written in reduction form. Okay. Okay, E naught. What is E naught? E naught is standard electro potential or standard reduction potential. We always use this one, standard reduction potential, SRP. Standard reduction potential, easy to remember, SRP. Saja rendah pelajaran. Okay. The sign of E naught changes when the reaction is reversed. If you reverse this equation, because if you look at this equation, this is in reduction form. Okay, if you reverse, it's become oxidation form. Okay, if we reverse this reduction form, it will become oxidation form, and we have to change the sign. For example, from negative become positive, positive become negative. Changing the stoichiometric coefficient does not change the value. Okay, sometimes we have to put 2Na plus 2E equal to 2Na, like that. Okay, we change the stoichiometric coefficient, but the value of E naught does not change. All right. And then, okay, we will use this. E naught positive, forward radiation predominate. Okay, remember this one, more positive red cat. Okay, more positive, reduction at cathode. Okay, it will become, it will reduce at cathode. Okay, remember this one, more positive red cat. Okay, standard reduction potential. Okay, we still do. Yeah, okay, no. Okay, the sign of E naught changes when the reaction is reversed, as I mentioned. Mg2 plus plus 2E Mg, E naught is negative 2.37. Okay, if we change this equation, become Mg solid, and then arrow Mg2 plus plus 2E, we just change the sign from negative to positive. The value is still the same, 2.37 volt. Okay, this is rule number 1. The same thing goes to fluorine. All right. Okay. And then note 2 is changing the stoichiometric coefficient. Does not change the does not change the value. For example, Al triple plus 3E equal to aluminum solid. E naught is negative 1.68. Okay, sometimes we have to put a factor 3 here. Okay, 3 is become 9, it's become 3, but the value is still negative 1.68 volts. Okay, all right, and then okay, we have 9 minutes more to go. Okay, standard reduction potential, indication of the sign of E naught. Okay, this, right. Okay, now we have two half equation. Chlorine, Cl2 gas plus 2E, 2Cl minus. And this is E naught of chlorine, positive 1.336 volt. And then we have bromine. Remember, bromine standard condition is liquid. Br2 liquid plus 2E, 2Br minus aqueous. Okay. And this is oxidant. Okay, remember this is oxidant because chlorine here reduced to Cl minus. Okay, this is oxidant, and this species we call it a reductant. Okay, Cl minus, reductant or reducing agent, oxidant, also oxidizing agent. Okay, okay. If you have these two equations in reduction, okay, in reduction, but in overall equation, one of these equation must be in oxidation. Okay, which one? So we will use this one, more positive red cat, more positive red cat. Which one is more positive? This one is more positive. Okay, Cl2 positive 1.36 volt. This is more positive than bromine. So chlorine favor the forward reaction, whereas bromine favor to reverse reaction. Okay. All right. So forward. Okay. Chlorine tend to accept electron and so on. Chlorine is easier to be reduced, as I said before. And okay. Okay. The strength. Okay. The strength of oxidizing agent, okay, this is oxidizing agent. Oxidant is oxidizing agent. Because this is more positive, chlorine is more, the strength of oxidizing agent, chlorine is more strength than bromine, okay? Bromine less than chlorine. The strength of reducing agent, bromine. Br minus, not bromine, Br minus, Br minus. Okay, minus is because look at this part, this is a reductant. This is more negative. So it's like this is reverse. Okay. If this one is strength, this means for oxidizing agent, for reducing agent, then Br minus will be stronger than Cl minus. Okay. All right. Okay, this is question. Okay, rank the relative strength of oxidizing agent and reducing agent. We have three. We have three now. Okay, NO3 minus equal plus 4H plus 3E and so on. Okay, if you look at these three equations, all of them in reduction form. Okay, because electron. Look at electron here. Electron at our left hand side. Okay, all of them in a reduction form. Okay, so to rank them, okay, in terms of oxidizing agent, remember more positive red cat. Which one is more positive? Positive. Okay, this one. Positive 1.3, positive 1.23. So, okay, this is oxidizing agent, MnO2. This is number one, all right? And number two is here. Yeah.
Ibu Shahnon, maybe
Yeah,
you
yeah.
can tell them the fourth class code. Last class code.
The last code is number 3. The last code is number 3. Okay. Okay. Okay, this is number 2 lah. This is number 2 because positive 0, and this is the third one, N2. Alright, this is the answer. This is how we rank oxidizing agent. MnO2 solid bigger than NO3 minus and bigger than that. Okay. Remember that more positive, right, cat? Okay. If we remember this one, more positive. Which one is more positive? Okay, reduction at cathode. Okay. And then reducing agent. Okay, we have to look at this species, and it must be reversed. It must be reversed from this one. All right, this one is more negative, N2H5 plus, and then followed by NO gas and Mn2 plus. Okay, this is for reducing agent. Okay, reverse from oxidizing agent. But you have to choose the correct species. Okay, for oxidizing agent, always choose at our left hand side. For reducing agent, always choose the species at our right hand side. Okay. Okay, more positive red cat, as I said. Okay. Okay. This is the uses of standard electro potential. Number 1 is determine the electron flow, determine the species being reduced. Okay, I've said this one. Build up the electrochemical series and calculate cell potential of opposite cell and predict stability of ion. Okay, actually now is 57. Okay, I think this will be okay. This is what? Okay, this no. I think I want to show this one. All right. Question 2. Okay, question 2. Describe what would you expect to see happening to both electrode compartment after a period of time. Account for your answer. This is the question. We have a zinc electrode here as an anode and zinc 2 plus as a electrolyte. Okay, so at the anode, this is how we write the equation. Zn solid to Zn2 plus 2E. Okay, why? Because at anode we know this must be oxidation from 0 to hero. No, from 0 to positive 2. Okay, oxidation number from 0 to positive 2. This is oxidation. At cathode, reduction. This is copper, Cu2 plus 2E. Okay, become Cu solid. So overall equation, we can write the overall equation. Okay, we will Zn solid, Cu2 plus, and Zn2 plus, and Cu2 plus. Okay, now describe what we expect to see. Okay, number 1 is the mass of zinc electrode reduced because from zinc becomes Zn2 plus. So the mass of zinc will reduce after a period of time. And the mass of copper electrode will increase because Cu2 plus here will deposit to the copper cathode here. Will deposit to here. So the mass of copper electrode will increase. And the color of Cu2 plus solution will fade because we know that the color of Cu2 plus ion is blue. And when it's become less and less, so the color will fade. Okay. Okay, I think this is the last one. Determine the cell potential. Okay, cell potential. We are running out of time. Okay. Okay. This is how. This is the formula we use to calculate the E naught cell. Okay, we already know the E naught of half cell, and now E naught cell. This is the formula. E naught cell equal to E naught cathode minus E naught anode. All right, and we know that copper is cathode because we use more positive red cat. This is more positive, positive 0.34. So copper becomes, the half cell of copper become cathode, and the zinc become anode, more positive red cat. So we just take take it as it's positive 0.34 minus, the formula is minus, and then minus 0.76. Okay, and it's become positive 1.10 volts. This is volts of this galvanic cell of zinc and copper. Okay, look at here. The E cell is positive, means this is spontaneous. Okay, I've mentioned before that galvanic cell, the voltaic cell must be spontaneous, so we'll get the positive. Okay, and the second way how to calculate the inert cell is, okay, this is anode. We write it in oxidation form. So we reverse this equation. C2 plus Zn2 plus 2E. When we reverse it, we have to change the sign of zinc. Okay, the sign of zinc is negative here. Now it's become positive. Okay, and then for zinc, okay, because this is in reduction, no problem. We just take positive 0.34, and after that we get the overall equation, and we just add this E naught. It's become E naught cell, positive 1.10 volt. This is two ways how to calculate the E naught cell, by using formula E naught cell equal to E naught cathode minus E naught cell, or with this equation, when the anode, the formula must be in oxidation form, and because of that we have to change the sign of E naught, because E naught given in reduction when it's become oxidation, so we have changed the sign, and then we just add, and then we will get positive 1.10. I think because we are running out of time, so I end my my lecture. I think my lecture here, and then I pass this to Teacher Tang. Okay, Teacher Tang.
Terima kasih Cikgu Shahnon. So, selesailah kelas kita pada petang ini. Tahniah diucapkan kepada semua yang setia bersama kita dari awal sehingga saat ini. Sebelum kita tamatkan sesi siaran langsung hari ini, mohon tutup ruangan chat dan klik button subscribe dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas yang seterusnya. Sekiranya kamu suka dengan apa yang dipelajari hari ini, sila klik like and share kepada rakan-rakan di sosial media anda untuk sebarkan ilmu dan peroleh kebaikan di atas perkongsian tersebut. Sila type down di ruangan komen sebelum link CJ akan diberikan sebagai tanda terima kasih daripada Cikgu kepada kehebatan kamu menyertai kelas tuition percuma pada hari ini. Link CJ boleh didapatkan pada bahagian chat. Sila ambil perhatian, link tersebut akan tamat tempoh setengah jam selepas live ini. Pastikan anda guna email e-direct sahaja. Kesalahan memasukkan email tidak akan dilayan. Kelas seterusnya untuk subjek kimia PAYU adalah pada minggu hadapan pada waktu yang sama. So, Ahad 3:30 petang. Kamu dijemput untuk ke portal www.academyyoutuber.com untuk dapatkan info terkini dan bantu Cikgu untuk sebarkan kelas tuition percuma ini kepada rakan-rakan dan guru-guru di seluruh Malaysia. Usaha ini adalah hasil gabungan guru-guru seluruh Malaysia untuk semua para pelajar seluruh negara, terutamanya dalam menghadapi saat genting melawan pandemik COVID-19 sekarang. Semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat hashtag bermula percuma, selamanya percuma. Terima kasih kepada semua penyokong Akademi YouTuber. Doakan kami terus kuat dan bersemangat untuk membantu untuk membangunkan pendidikan Malaysia. Bye.
Wow, banyaknya hadiah menarik menanti anda. Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.